In the vast expanse of time and space, amidst the quiet contemplation of existence, let us ponder the intricate dance of harvesting solar power from the boundless embrace of sunlight. Step by step, with a somber cadence, we embark on this solemn journey. Initially, photovoltaic cells, delicately poised, absorb photons of light, initiating a silent conversion process. Gradually, electrons dance with purpose, generating electrical currents that traverse the conduits of our civilization. Yet, in this grand symphony of energy, challenges may emerge. Yet, with relentless dedication and unwavering practice, we traverse the shadows, mastering the art of harnessing solar power, illuminating the path to a sustainable future.
Embrace the chance to study now, as your success solely depends on you. Seize the opportunity and let your determination and effort pave the path to knowledge and greatness. Remember, do the things to yourself because nobody else will.
Title: Mastering Solar Power, a comprehensive guide to harnessing the sun's energy. Introduction. In an era of environmental consciousness and renewable energy, the quest for harnessing solar power has become paramount. Join us on an illuminating journey as we explore the intricate process of capturing the sun's radiant energy and converting it into usable electricity. From the materials used in solar panels to the science behind their efficiency, we delve deep into the fascinating world of solar energy generation. Step 1. Understanding solar panels. Solar panels, the cornerstone of solar power systems, are composed of photovoltaic cells that convert sunlight into electricity. These cells are typically made from semiconductor materials like silicon or perovskite, which have unique properties that enable them to generate electricity when exposed to sunlight. Step 2. Materials used in solar panels. Silicon, the most commonly used material in solar panels, is abundant and has proven to be reliable and efficient in converting sunlight into electricity. Perovskite, a newer material, has garnered attention for its potential to increase the efficiency of solar panels and reduce production costs. Step 3. Solar panel shapes and designs. Solar panels come in various shapes and designs to accommodate different installation requirements and maximize energy output. Traditional flat panels are the most common, but advancements in technology have led to the development of flexible, thin film panels that can be integrated into building materials or curved to fit curved surfaces. Step 4. The photovoltaic effect. The photovoltaic effect is the phenomenon by which solar cells convert sunlight into electricity. When photons from sunlight strike the surface of a solar cell, they excite electrons, causing them to move and generate an electric current. This current is then collected and converted into usable electricity. Step 5. Efficiency and performance. The efficiency of a solar panel refers to the percentage of sunlight it can convert into electricity. Factors such as the quality of materials, design, and environmental conditions can affect a solar panel's efficiency and performance. Maximizing efficiency is crucial for optimizing energy production and reducing costs. Step 6. Installation and maintenance. Proper installation and maintenance are essential for ensuring the long-term performance and reliability of solar power systems. Solar panels should be installed in locations with optimal sunlight exposure and kept clean to maximize energy production. Regular inspections and maintenance can help identify and address any issues that may arise. Conclusion. As we conclude our journey into the world of solar power, we are reminded of the immense potential and promise of renewable energy. By harnessing the sun's abundant energy, we can reduce our dependence on fossil fuels and mitigate the impacts of climate change. Let us embrace the power of the sun and usher in a brighter, more sustainable future for generations to come. Title: Unveiling the Potential of Solar Power, a concise guide. Introduction. Welcome to an enlightening exploration of solar power, the key to a sustainable future. In this concise guide, we'll unravel the mysteries of harnessing the sun's energy through solar panels, from materials to installation. Materials used in solar panels. Solar panels are primarily composed of photovoltaic cells, typically made from silicon or perovskite. Silicon, abundant and reliable, has been the cornerstone of solar panel production. Perovskite, a promising newcomer, offers the potential for increased efficiency and reduced costs. costs. Shapes and designs of solar panels. Solar panels come in various shapes and designs, from traditional flat panels to flexible thin film options. These designs cater to different installation requirements and can even be integrated into building materials. The photovoltaic effect. At the heart of solar power lies the photovoltaic effect, where sunlight excites electrons in solar cells, generating electric current. Understanding this phenomenon is crucial for maximizing energy production. Efficiency and performance. Efficiency is paramount in solar panels, affecting energy output and costs. Factors like materials design and environmental conditions influence efficiency and performance. Installation and maintenance. Proper installation and maintenance ensure long-term performance. Solar panels should be installed in sunlight-rich areas and regularly inspected for optimal function. Conclusion: solar power holds immense potential for a sustainable future. By embracing solar energy, we can reduce our reliance on fossil fuels and combat climate change. Let's join hands in harnessing the power of the sun for a brighter tomorrow. Closing remarks. Your engagement is vital. Like, share, and comment to boost this video's visibility, and subscribe for more insightful content. Your feedback will shape future videos to meet your demands. Check out the links in the description to explore our sponsor's website and embark on your solar power journey today.